Hi, Engineering Space Cadet. So today we're going to go over bitwise operations. What are bitwise operators and operations? So within Python, they are ways of handling bits. So everything such as characters and integers and float point numbers and all these things in between can be handled as bits because bits are the only thing that a computer understands. Whether it's a high level or a low level, bits are how computers understand things, whether it is interpreted and turned into bytecode, and then that bytecode is then turned into bits for the computer to understand, or from the lower level where you write assembly or C code. All these things from the higher level to the lower level are bits. Now we've definitely abstracted away from just writing basic ones and zeros, but if you don't know what bits are, we're going to go over that in this video, and then we're going to show you how those bitwise operators are explained within Python. Let's get started. On the spaceship, now I'm a space cadet. Big white legend in my habitat. So, what are bits? So, bits here can be thought of as a state of a electrical signal. But in very simple terms, we're just going to take this as a light switch, right? And if you're familiar with light switches, you can have an on and an off. And there are other kinds of light switches here, but we're going to go to the most basic version of a light switch. So we're going to have an on and we're going to have an off. And then we have two different states. One being off, which is going to be a 0, and one being on, which is going to be a 1. Both of these are representing states. Now, computers are very clever, but essentially we just have a bunch of switches, tiny little switches called transistors that will turn something on or off, open something up or close it, right? That's all we need to really worry about. So from here, we can think about binary as just being these ones and zeros. Now, if you've ever seen something like 1, 0, 0, 1, or 1, or just 1, or 1, 0, or maybe like 1, 1, 0, 0, or maybe it's a 0, or just any combination of things. These all have values within the computer. They all mean something. And to break that down even further, a bit is just one of these. Just one of these. So multiple bits would make up something that is a binary number. And a binary number just means 2. Binary, BI, that just stands for 2. And nary, I don't know. Nary, I'm not sure what that means. So I'm not even going to worry about that, but we're just going to think about the prefix here. So when we think about this binary number, that means that we have two states. And normally we can separate this out to having a base 2. 2 to some power n, right? And that means that depending on the position, let's take this like if we were doing a little register or something, where we have 0, 1, 2, and 3, where we're kind of incrementing up this way. So we have 2 to the 0th power, 2 to the first power, 2 to the second power, and then 2 to the third power. And you're like, okay, maybe I'm not as familiar with my math. I'm not sure exactly what these mean. So I'll just tell you the simple way of doing it. So if we have one of these blocks filled in, if we have one of these blocks like this filled in with a 1, that means it's on, or it exists. If it has a 0, then it's off, or it doesn't exist. Or it doesn't exist, yeah. So we'll just keep it here. And for here, any one of these blocks has a different value. Now, what these actual values are full of, when they are full, these are going to be the max values at each one of these points. From 2 to 0, the max value is going to be 1. 2 to the first is going to be 2. And then for 2 to the second, which is going to be 4. And then 2 to the third, which is going to be 8, which is just basically Here, so it's going to be 2 times 1, 2 times 2, and then 2 times 2 times 2, right? So that's all these threes are, right? That's essentially all it is. It's some value where we have 2 to the something power, and it just represents whatever this value may happen to be. Now, not that important, but what can we do from here if we add all these numbers up together, right? If we add all these numbers up together, what do we get, right? So the total number that we could do if we add all these numbers up together is 15. So that means that we can represent numbers from 0 all the way up to 15. Now, if we want to represent more numbers, we could just add more of these blocks, right? But for now, we're just not going to worry about that, and we're just going to give some examples for certain numbers. So we'll do a basic number that's between 1 and 15, right? So we'll just start here. Let's do a number like 0, 0, 1, 1. Based on the rules that I established, can we break this down to get an actual number equivalent from this binary number, right? So our binary number is going to be equal to 0, 0, 1, 1. Now that has an actual integer value. So what is that going to be equal to? That's what we're trying to figure out. So based on the rules, we're going to just fill in underneath these boxes what the max value is, which we're going to have 8 here, 4 here, 2 here, and 1 here. Now, any of these values that has a 1 in it, it exists. And if it doesn't have a 1 in it, then it doesn't exist. So it doesn't matter. So the only two that matter in this particular case are this one right here and this one right here. So we're just going to add the two numbers that have 1s in them up. So 2 plus 1, and that's going to give us a 3. So our integer for this binary number is actually 3. No problem. We're going to do one more example really quickly. We're going to have 1, 0, 1, 1. We're just going to break this up one more time. And this is just something you're probably not going to have to worry about too much later, but it's just an easy way to kind of understand it. Our binary number is going to be equal to 1, 0, 1, 1, and then our integer value is going to be equal to something that we're trying to find out. Now, all the ones that matter is this one here, this one, and this one. So we have 8 plus 2 plus 1, which will just basically give us 11. So our integer value here is going to be 11. Pretty straightforward, very basic arithmetic. So why does that matter? So when it comes to Python, we have basically ways of handling this data, which we have something called an and, we have an or, we have a not, and we have an XOR. And then we have something that's like shifting, which is just shift left or right. And these are going to be our basic bitwise operators that we're going to be concerned with. Essentially, we're just going to start with an AND gate and what that means in terms of binary. And basically, we're just going to start off representing our bits with an A and a B. So these are going to represent our bits. So we're going to have an A and a B, and we're going to do a combination of these A's and B's and get some kind of result out, right? So that's all that matters. So we're going to take this here, this result, just put it down here so we understand where it's supposed to go. Now we have combinations like 0, 0, 0, 1, 1, 0, and 1, 1. And if you just notice here, we're just counting up from 0. So we have 0, 1, 2, and 3. You could do the binary addition just to figure that out. But essentially right here, we're just counting up to 3. So we have, a total of 4 states that we can possibly do. And an and means, in this context, that we're going to take these numbers, like A plus A, well, not plus, but A and B, and this and is just multiplication. And that will get us our result, right? No problem. So if we have a 0 here and a 0 here, 0, 1, 1 0, and then a 1 1. We're going to go back to just our basic arithmetic, and this will represent all of our values possible. So 0 times 0, anything times 0 is just going to be 0. So we can shorthand this. 0 times 1 is still going to be 0. 1 times 0 is still just going to be 0. And then 1 times 1, anything multiplied by 1 is just going to be 1. So 1 times 1 is just going to be 1. And that's going to be our result for and 0, 0, 0, and 1, right? No, not too much of a difficult topic there. So let's just scroll up a little bit more, and we're going to continue on to our OR. So an OR is we're going to have the same context here, and we're going to do the same thing where we have a result, and we have an A and a B and some kind of result. For OR, it just means add. So we have a 0, 0, 0, 1, 1, 0, and 1, 1. Now we're just going to do the same thing, 0, 0, 0, 1, 1, 0, and 1, 1. And we're just doing addition between each of these, right? Nothing too crazy. Essentially, this is going to be 0 plus 0, 0. 0 plus 1 is going to be 1. 1 plus 0 is just going to be 1, and then 1 plus 1. Since binary only handles states of 1, all you really have to worry about is that 1 plus 1 is just going to be 1. You know, you can't get a 2 out of that, so we're just going to give ourselves a 1. So this is just going to be our OR right here. 1, 1, 1. Cool. Now we're going to move on to a not. So a not is very interesting in the context, right? So we have a not, which is just going to be something as a result. And not is just going to be the opposite, right? No, I spelled opposite wrong. No one ever said that I was good at grammar. Opposite. And if we have a 0 in here and a 1 here, whatever is not A is going to be 1, and whatever is not 1 is going to be 0. Cool. No problem. That's just a very basic not. However, in Python, it's a little bit more interesting. Okay, so essentially, what we're going to do is something called a complement. Well, it's not letting me write all these letters. Complement. And essentially what that will be doing is we'll try to figure out what the opposite of something is. So if we have, for example, a 0, we're going to add a 1 to it, right? Or for 1, we're going to add a 1 to it. But essentially, for a complement, we take in additional positions. So we add a 0, we add a 1 to whatever we have. So it may seem a little confusing at first, but let me try to explain it in a simpler way. So we're going to take this number like 0, 1. And to get the complement, we're going to add a 1. Now, we have our rules about what we can do with a 1, right? 1 plus 1 normally is just going to give us a 1, right? And, you know, there's nothing here. However, in the context of Python, a 1 plus 1, or for this complement here, essentially, is we're going to do something called a carry, right? So if we do have a 1 plus 1, like this, we're going to carry that value over to the additional value. So essentially, this 1 plus 1 is going to give us a 0. And then we're going to carry this over to the other one, which will just give us a 1 here, which is just giving us the opposite of what we had, right? So we can do the same thing here, where we have a 1, 1 plus 1, and this will be a carry, 0, and then 1, and then this will be a carry as well, which would be a 0. And then this carry value right here would technically just be a 1, right? And, you know, that can be helpful to understand that whenever we're looking at the not within Python. It may not make as much sense right now, but it'll make more sense later, hopefully. So we're going to go into our final three, which we have our XOR, and we're going to keep our A and B, and we're going to have our result as well. And we're going to have the same thing, 0, 0. Yep, 0, 0, 0, 1, 1, 0, and then 1, 1, and then our result. Okay, so this one's a little bit more complicated, but essentially, if you think about it this way, it makes a lot easier. If it's not 0, 0 or 1, 1, then it's if it's not 0, 0 or 1, 1, then it's 1. Otherwise 0. Cool. So in this case, if it's 0, 0, then it's 0. If it's 1, 1, then it's 0. If it's 0, 1, then it's 1. If it's 1, 0, then it's 1. And this is our exclusive OR. Maybe there's probably a mathematical function that explains it better. I just don't remember it at the moment, so I'm just going off the top of my head and just going to continue here. Okay, so now we're just going to think about this way, and we're going to have a shift. Now, a shift is just going to be putting a value and shifting it to the left or to the right by however many spaces. So let's say, for example, we have something like 0, 1, and we shift by 1. This just means that we're going to move that 1 into its next position. And then we fill that position in with a 0. If that happens to be the case, right? So then if we shift this by 1 to the left, then we're going to push it up, which will just be 1, 0, like this. Because we're doing a step up. Now, if we were to shift this by 2, for example, we would have 1, 0, 0. And if you can see that, we're just doing a shift by 1 essentially and just keep shifting that way. Now, if we shift to the right, we're essentially just taking that value here by 1, and we're just shifting to the right by 1. So if this was the case, for 1, 0, we shift it to the right by 1, and that would just be 0, 1. And then if we shift it by 2, it would just be 0, 0. And then technically it'd be over here, but don't really need to worry about that because we're only going to be looking at what if we're shifting at these 2 points. Okay, so essentially that's going to be our basics for our bitwise operators. I know it's a long video and I know that that's a long concept to go into, but it's very important for this next part. Okay, so let's go into some coding to kind of understand the basics of that. Give me one moment and transition. Okay, so now that we have that out of the way, and again, I get it. It's a lot of information very quickly. If it was just a review for you, skipping to about right now would be fine. We're just going to take these additional topics and build on it for our bitwise operators. Okay, cool. So let's get started with some very basic numbers. So we're going to have 2 variables, x, and we're going to equal x to 1. And then we're going to have y, and we're going to equal that out to 1 as well. So, no problem. what we're going to do is we're going to represent these values, and we're going to put these in comments as the binary value. So the binary value is equivalent to 0, 1. And the same thing here. The binary value is equal to 0, 1. So that means that based on the rules that we're giving to it, if we wanted to, we could print out the values. And we're going to use a function called bin that will allow us to see the binary value. And here we're just going to print out x, and then we're going to print out the binary value of y. Fantastic. We're just going to run this real quick. Cool. Means the same thing. It has a z, or it has a 0 here, and it has a b1. Now, essentially, when there's a 0 in front, we kind of ignore it. So that's why you have a binary of 1. Now, if we had something like a 2 here, this would be 1, 0. Change this value to 2. And you can see that that number here is going to change to a 1, 0. And that is because when it's a following 0, then we do not ignore it. But if it's a leading 0, then we definitely ignore it. So essentially, both of these numbers could be represented as 0, 0, 0, or however many zeros we want to put in front of it. And we could just keep doing that. But it doesn't really help us that much, right? So let's take into account 3 cases. So we're going to print out 3 different cases. We're going to print out, I forgot to include the symbols in the previous explanation, but essentially here we have our symbols. So we're going to symbols for and will be equal to this symbol. For or, it's going to be equal to this symbol. For not, it's going to be equal to this tilde. And for XOR, it's going to be equal to this symbol here. And for a shift left, it's going to be equal to this. And then a shift right is going to be equal to this. Now, based on the rules that we had previously, let's print out the cases. So we're going to have this here. We're going to have this as an AND case. Then we're going to do a very basic OR case. And then we're going to do a basic NOT case. Hopefully this will clear up some of the confusion. And then we'll do a basic XOR case. And then we'll do a shift left, and then we'll do a shift right. Shift right. And then we'll just print this value here. Oh, sometimes I write code too fast and mess up a lot of stuff. Okay. So based on how we're going to address each of these cases, we're going to do right here for this and essentially what we'll be doing is we'll have a 0, 1. Just hashtag that. Have a 0, 1 plus or and a 1, 0. And that will give us some kind of result, right? Now, if we remember the rules for an AND, they have to be the same in order for them to come out as a 1. So it's 0 and 1 here are not the same. That on our right side is just going to give us out a 0. And then our 1 and our 0 here are not the same, so that's just going to give us out a 0 as well. In our OR case, we're going to have that 0, 1 or 1, 0. And this will just come out as 1, 1 because we do have a 1 in the first position and we have a 1 in the second position, right? And a not, we'll take this number, we'll take any number like x, for example, and then we'll say not x, which should just flip this into whatever the opposite of this is. So if it was a sign positive, as in 0, b, and then 0, 1, then the opposite should be like a negative 0, right? A negative 0. And then b, and then 1, 0. And this is because we technically add a 1 here. And this will take that and shift it here. And for y not y, it should be about the same, right? So it should be a 0, which is binary of 1, 0. And then that should be equal to basically a negative. I would normally say negative 1, but that doesn't really make much sense in this context, I guess. Because it's either going to be a 1 or a negative 0. So it means the same thing. And this can be a 1, 1. So then when it comes to XOR, since 0, 1 and 1, 0 and 1, 0 both have 1s in them, but they're alternating, this is just going to give us basically a 1, 1. And then we'll do like a shift. And shift to the left for y, which should be equal to a 0, 1, and then a shift to the right. To the right. And we're going to do the shift by 1. Should have y then equal to 1, 0, but if we shift it again, we'll shift this one by 2 just to show, and it should be binary equivalent of this, which should be 0 and then 0 binary, which will essentially just give us 0, 1, 2. So nope, we'll put it even further up. And that should just be equal to 8. This should be equal to 1. And hopefully I did this all correctly, so it should give us a good explanation of how these things are working. So x and y, because those are the symbols. Then we do x or y. This is equal to 3, by the way. So not x. So we're going to print out not x. And then for x or, we're going to have 0, 1. Let's see. X or, let's see, 0. That. Actually, y. XOR. And then we're going to have our x shifted to the right, or y shifted to the left by 1, and then we'll have a y shifted to the right by 2. Let's just run these. Okay. Let's see. Ooh. Oh, I switch these up. I switch these up in my head. Shift to the left goes up. Shift to the right by 1, actually. I messed these up. My bad. There we go. So shift to the right by 1, and this should be 1. Shift to the left, which is just making me go up 1 level. That should just be, this is 1 0. Should be 0 0 0, which should just be 0 0 binary, which that will just be 4. Okay. And yeah, so here you can see that, and let's run this again. Now you can see that and here, x and y will just have 0 1 and 1 0, which will come out as 0 0, which is just equal to 0. And you can see that x or y is going to be 0 1 or 1 0, which is just equal to 1 1, which is equal to 3. You can see that this is not so not x. You can see right here, not x. It just comes out as -2 here. If we do print not y as well, print not y. Okay, cool. Which this gives us a -2, and then this should be equal to -3 if I'm not mistaken. And this right here should give us 3, which it does. And this shift here. Ooh, I have an idea. This will make it a little bit nicer to look at. Okay. So, yeah. So as you can see here, for this and, if we add those up together, if you see for here, if we add these together, it gives us 3. Not this gives -2. Not this gives us -3. And for this XOR, you can see that that is 3, which is what we got. Yeah, that's equal to 3. The shift by 2 is equal to 8, which you can see here. And shift by 1, you can see that it's equal to 1. All right, so basically that's our bitwise operators. We can also do the same thing that we did with our other operators, which are these here. And you can see that you have these plus equals, and you can do the same thing with all these other operators for bitwise. But I think that this right here is just the basics. Sorry if the video is taking too long. I just kind of want to go over the bitwise a little bit better. I did make a couple mistakes, which is fine. You know, happens in coding. I do understand the logic, but sometimes, you know, my brain gets a little Anyways. In the next video, I'll go over something else that I think is pretty fun. Okay. See you next time, and thanks for watching.